Hi, everyone. My name is Vanya, and today I would like to share our experience playing around with React Native at Traveloka. So before going into my presentation, I would like to confess that this is actually my first time speaking at a conference. So it's a bit intimidating. It's quite different seeing you guys from up here. So with that being said, if any of you notice any mistake from my side, I hope you won, because I don't want to overthink it for the rest of my trip. Okay. Thank you, guys. I need that. Okay, with that out of the way, let me reintroduce myself. I'm Vanya from Indonesia. I am currently working at Traveloka as an engineering manager of a team called Multi-Platform Infra, where we do every core infrastructure work related to developing solutions that can be used on multiple platforms. And we have been heavily using React Native for over 5 years now. So let me start with introducing Traveloka first. Traveloka was founded in 2012. It just had its 10-year anniversary several months ago. And Traveloka now is a lifestyle super app that has 100+ million app downloads, providing 20+ products in travel, local services, and financial services across 6 countries across Southeast Asia and Australia. Now, as for the React Native part, back in October 2016, several engineers decided to do a comprehensive research on React Native. The goal was, of course, to see whether adopting React Native can be beneficial for Traveloka in the long run. Some tools that work for others might not work for us. This research was a necessity, of course. So we did research on 2 fronts. On the Traveloka mobile app itself, we created a whole new React Native-based product called Bills and Top Up on our pre-existing native application. We also did a proof of concept on our supply side by developing 2 B2B React Native applications from scratch for our hotel and attraction partners, Terra and Access. So it's not really a spoiler to say that the proof of concept worked. Otherwise, I will not be here speaking about React Native at Traveloka. It will be an entirely different topic. So over the years, the product being developed in Traveloka also grew, 6 of which are React Native products at our Traveloka mobile applications. These are like several pages that were built in React Native to showcase the breadth type of like our products. These are some more. Okay. And we also have 7 React Native based B2B applications from hotel partners, bus drivers, to food delivery drivers. So for the benefit, we think these are the 3 biggest benefits of using React Native. For us specifically, the first one is reusability, of course. We talk about this all the time, right? And then the second one, certain time to market. And the last but not least, reduce development bandwidth on a specific platform. Now, one of our goals, the team, is to maximize these benefits in Traveloka with architectural improvement resources and implementations. Now first, let's begin with the bird's eye view of our current architecture. We have what we call the district system. It is basically showcasing all the React Native related domains that we have been working on. So we have several district units here. The first one is core. Core is basically a set of libraries divided by its own distinct responsibility. At the center of it, as you can see, we have district util and district UI that contain common utilities and common UI components for our internal design system, respectively. We then have like several libraries built on top of those 2. These are only like the examples that we have. Now, these libraries can be used on every other district unit, mainly on the demand side, on the Traveloka mobile app, and also on the supply side, we have B2B mobile applications. Other than that, Traveloka desktop, web, mobile and B2B web tools can also use these core libraries as we are utilizing React Native Web. And one additional thing to note is that as we are utilizing React for our web development, web engineers can easily contribute to our core libraries or other district units. So moving on to the Traveloka mobile applications itself, we use the brownfield approach, meaning only parts of the whole Traveloka applications are developed using React Native. So for us, it's a matter of creating an environment that works for native Android, iOS, and React Native. So for this, we are using Git submodules. Basically, submodules allow you to include a Git repository inside another Git repository as a subdirectory. In our case, we have 3 individual repositories for Android, iOS, and React Native. The React Native repository, we call it District Traveloka, which only contains React Native JavaScript code in the SRC folder. Then includes Android and iOS repository as it got Git submodules. As you can see, District Traveloka then could have Android and iOS folders there. So this approach allows a clear environment separation between each platform, reducing context needed, especially for native engineers, because each engineer can work on an isolated repository. So when native engineers build their app from Android and iOS repository, we need to exclude our React Native code from there. But everything can be included only if it's being built from the District Traveloka repository. However, this approach introduces uncode breaking changes from time to time. For example, when there is a need for Android engineer to refactor something on the Android product A folder, they sometimes forget that you need to change it on the district folder as well. To get breaking change notification, we do a daily build from District Traveloka repository, as the build will always fail. And then another interesting thing about District Traveloka repository is that we have a shareable module to other district units that serve two purposes. The first one is for shareable product-specific building blocks. It is used for other products on District Traveloka if you want to share some building blocks to other district units, especially for B2B mobile applications. And the second one is for the mobile web version of the same feature on our Traveloka mobile web repository. So why did we put it on this repository instead of making it as one of the core libraries, you might ask? Yes, that can be done. However, that will also increase the development and maintenance effort that can be avoided, as the current approach works fine, since the primary development always happens on District Traveloka repository. So moving on, as we have products on both native and React Native sides, it's best to reuse things that already exist on the native side. We tend to create single source of truth on native side and prevent saving redundant data on React Native. For example, for our user session data. With that, we have various native modules, from accessing user data to complex image computations. And I will say that it comes down to the pros and cons of reusing native implementations by creating native modules. The first pro of reusing native implementation is that we have minimal maintenance effort. We only need to maintain the contract on our native modules instead of the whole feature, as the feature, the already existed feature, has been maintained by other team. The second pro is that if you need to create a high-performance, multi-threaded computation, then yes, it's always best to create it natively. And the last pro is that by using native modules, we can have a single source of truth of our data management. With those pro points, of course, it comes with several cons as well. And the first con is that we then have double development effort. If we need to develop reusable implementation on the native side, then yes, you need to create it twice for each platform. Not counting if the code is shareable to the web platform as well. And the second con is that sometimes there's a difference in platform implementation that you need to somehow bridge it. So basically, we assess whether we need to reuse native implementations or recreating it on the React Native side by weighing these points. Apart from that, not only are we sharing the code in the form of native modules, from as early as 2020, we also started researching on enhancing our interoperability between native and React Native with a single question. Is it possible to share UI components between native and React Native? And the answer is, of course, yes, but. So let's start from this standpoint. From rendering native components on React Native pages perspective, we know that this is not a new concept since React Native already supports creating custom components, custom native UI components. However, as far as the official documentation goes, native UI components can only be rendered on React Native if and only if the view is stretched using Flex1 or the size is explicitly defined. Whereas in our case, the components should be able to manage their own layout. So the goal is to make React Native be self-aware of layout updates that happen on native components so that we can have dynamic-sized native components. So when React Native side needs to render native components, you need to create a view manager that will initiate the components for you. For React Native to be self-aware of the component layout updates that we need to wrap the component to be rendered as a wrapper view's child. This wrapper view will then be responsible to observe size change and notify it to the UI manager. So for Android, we did it by overriding the onMeasure method. We measured the component's actual size and update it to the React Native side with UI manager model.updateNodeSize method there at the bottom. As for the iOS, we did by overriding the subviews methods. More or less the same as Android, we get the size of the components bound and set it to the UI manager. So it's pretty simple and straightforward solution. Now, on the other side of things, we also researched and found the solution on how to render React Native UI components on native screens. Now, the native components can define their own size. We use that as a single source of truth. Now, one single UI component can be shared to Android, native and React Native, iOS, and also web platform. We use it as well to share React Native product components to native products. So, how did we make it work? So actually, there is an official guide regarding integrations with native app. As we have experience with the brownfield approach, the way we render React Native components is not that complicated for us. The interesting part is how we create a communication tunnel between React Native and native. Our goal is to make the contract looks familiar for Android and iOS engineers. So I'm going to explain the communication definition with an example. We have an input field component here where it has value and unchanged props. And also, you can access the validate method, for example, from its ref. These three have distinct communication types. For number one, we use properties to pass primitive values from native to React Native. And we also use native modules to pass callbacks from React Native to native. The third one, we also use events to call React Native functions, in this case validate, from native side, and return the value back to native by using native modules. So let's take a look at the communication types one by one, shall we? So for the first communication type, properties, it's quite straightforward. We use React root view on the native side to render a React Native component. It has a method called App.properties to pass properties directly to the JavaScript side, like shown here. For the second communication type, callbacks, the JavaScript side, in this case input field, needs to call a native module every time the onChange method gets called. This native module needs to find the native input field view by using React tag. As the view implements a delegate or implements an interface on Android, we can access the delegate and call the onNotify method provided. And just like that, the component is notified that a change happens on the JavaScript side. The Android implementation is more or less similar to the iOS one. And the last communication type is events that we use to trigger React Native method from the native side. So for this, the JS side has to listen a specific event differentiated by its React tag. As you can see here, I use event ID. Why is it necessary? It is because we need to ensure that the native will trigger the event for the right JavaScript component. When the JavaScript side has been notified and has run the specific method, it returns the value of the method using the native module, just like the previous type. So for this, to sum it up, we use properties to pass primitive data from native to React Native, native modules for callbacks and return values, and the third one, we use events to trigger JavaScript methods. Okay, so the last but not least research that we did for Traveloka application is whether it is possible to release a specific product JavaScript code using CodePush. We call it independent release. For context, CodePush is an OTA update from App Center that enables React Native to deploy mobile app updates, in this case, JavaScript code and assets directly to their users' devices. So the goal for this is for each product team to be able to define their own timeline and release independently. So during our research in 2018, Traveloka released a new app version monthly. It creates a limitation for products to do fast iterations. If a certain feature timeline gets delayed, the team needs to either force the product to be released on time, compromising several pending ongoing tasks, or delay the feature to be released the following month. Other than that, independent release benefits users to only download the products or the Delta updates that they need. To make it possible, we need to do these two things. First, split the single bundle that we have to multiple bundles. And the second one, we also need to create in-house CodePush mechanism that supports that multiple bundle management. Okay, so for the first task, we split our single bundle, in this case, index bundle, into several products bundle and a single bundle that we call vendor bundle. Vendor bundle is a shared bundle, so React Native goes there, other dependencies goes there and everything. We did it by customizing our metro config. So after the separation is done on runtime, each product activity on Android or View controller on iOS is able to access only their product bundle and vendor bundle, and nothing more. For the second task that we need to do, let's first take a look at its original, at the CodePush original flow. So for CodePush to happen, the JS entry, in this case product entry, needs to request CodePush to sync. Basically checks for and applies available updates. And the orchestration happens on there, on the JavaScript side. CodePush.js will then can connect to the native modules to download, bundle, or apply it, and it can also connect to the acquisition SDK to handle all API calls. On the native side, product activity and product view controller, we only need to get the bundle path from CodePush native side. So for this, we have to make several changes to make it work for us. As we are currently handling multiple bundles at the same time, we need CodePush to be able to handle that by creating CodePush instance for a single bundle. We also need it to be developed natively and decoupled from React context. With that, we can trigger updates checking from anywhere we want, even when it's on background surface or on our homepage and everything. This means that the JavaScript code for these in-house solutions only handles report success only if the bundles are successfully applied. So we are at the end of the presentations. To sum everything, our architecture improvements are more often based on the benefits that I shared at the beginning. Our district system maximizes the reusability level. We have core libraries that are shareable to every other unit for each platform, Android, iOS, and web. It doesn't matter if it's on the demand side or supply side. That also, in a way, contributes to the certain time to market, as everything shareable has been developed. So you don't actually have to start from scratch on bootstrapping a new application. And then, if we talk about how we even share React Native and native UI components between the two, of course, it is back to reusability and certain time to market. But it also opens up the possibility that we don't need to create something from scratch on the native side if the products are fully in React Native and vice versa. By using React Native, we can maximize having one knowledge pool for both React Native and web. And not to forget how enabling independent release also contributes a lot to certain time to market. Each product can manage their own release timeline, just like how we usually do it on the backend side. So there is still a lot that we can and will do with React Native, not to mention the many things to unpack from each point I presented that cannot be explored in this session. But I hope this presentation can give you a better understanding on how we utilize React Native to maximize its benefit at Traveloka. As I've said in the beginning, some tools that work for others might not work for us. I hope you can take something beneficial away from this presentation. That's it. Thank you. Thank you. So if you want to know more about React Native at Traveloka, you can read our articles on Traveloka Engineering Medium. All of our articles are prefixed with React Native at Traveloka, so it will be easy for you to find. Thank you, everyone.